Voice clear, audible?
Yes, sir.
Great. So thank you very much. I want to thank Mr. Shankar, Mr. Shamal Burman for the coordination and giving us this opportunity to share our knowledge from the E111 ISRE technical group on UVGI solution. During the pandemic, the UVGI TG was put together by ISRE. The way we have so many technical groups, UVGI technical group need was felt around that time, and our team was put together. So we have members from all across the HVACR fraternity. So we have representatives from the manufacturer side, consultant side, contractors, dealers who sell UVGI, also end users representing software companies, hotel industries, and hospitals. So it's a very good mix and mix of experienced professionals who have given all their inputs. So through this presentation, we are spreading the knowledge and awareness about the capabilities of UVGI in disinfecting pathogens in the HVAC or industry, and also going beyond the disinfection, what further benefits it offers. So this is what we have put together. You will find the agenda to be quite comprehensive, which uh, actually is a contribution from different group members, end users, consultants, UVGA manufacturers, contractors. So a lot of practical information also we have put into this presentation. Through this presentation, we will be able to uh, answer many anxieties and concerns, fears, I should say, which we were hearing during the pandemic time. People were worried from UVGI, there will be a ozone generation which will affect the health of people. If UVGI glass breaks, what happens? Will there be any problem with that in disposing? What kind of intensities are needed? Because different companies were giving different values of microwatt per square centimeter or microjoule per square centimeter. So which is the right number? Should it be installed before the coil, after the coil? Will it affect our eyesight? All these kind of fears were there, including there were questions about material compatibility if you put the UVGI inside AHU. There were questions like, will it melt the wires inside the AHU, which are powering the AHU blower motor? And also, will it react with the V-belt of the drive, AHU blower drive? All these kind of practical questions were there, which we understand. So through this presentation, if you see the agenda, almost everything we are touching upon. So we will start with history, how it works, how it disinfects, the type of lamps, which standards are applicable to define the performance and safety standards, exactly how do we apply it for HVAC disinfection. More than disinfection, it also helps to enhance indoor air quality and also delivers energy saving, because many corporates, many clients are looking for going for net zero. They have a goal to help the country reach net zero by 2070 as per the government's declaration. So UVGA also can do a little contribution towards that journey. How to safely handle UVGI? The maintenance aspects, there are quite a few from our experience. And in healthcare, UVGI finds a very widespread use. So we are going to touch upon that a bit, and then we will summarize. So if you remove all the title slides, I have about 60 slides, which conveys key messages. So I should be able to complete this in about 70 to 75 minutes. Then some 5-10 minutes we can have question and answer, and then we will wrap up the session. If at all you are getting any queries, any input you want to give, maybe I request you to jot down. So at the end of the presentation, we can discuss about this. So let us start with history and the basic information of UVGI. Now, before we start, we all are familiar with the UVGI used in the water purifiers at home. So the UVGI used for water application is different from the UVGI that we are going to use for surface disinfection and airstream disinfection in HVAC. The attenuation of the UV rays that occurs in water is different. The way it happens in air is different. The kind of energy dosage we impart to water stream is different, air stream is different. Okay. So because of these differences between the two applications, the current ISHRE E111TG is focusing more on whatever pertains to HVAC design. So we will be focusing on surface disinfection and airstream disinfection. So in this presentation, as of now, our group is not handling water disinfection. Maybe sometime in future, it may get added. So this presentation is going to talk about everything about surface disinfection and air disinfection. A quick glance at the UVGI history. We all were pleasantly surprised to know that for more than 150 years, UVGI is known. So if you see the slide where my pointer is moving, right from 1877, when this was demonstrated, using sunlight, we can disinfect bacteria. 1903, a scientist, he got a Nobel Prize for using UVGI. So you could have a look at all these points. And during the Second World War time, to treat TB, there was no vaccine that time for TB. So in the US and all developed countries, many public places like schools, colleges, train stations, etc., they used the upper zone irradiation unit. So it was quite popular right during the Second World War time. Even some of the ASHRAE handbooks, you will see some very old photographs of those times, how it was used. But the recognition started happening only from the later part, that is in the 21st century. 2003, the CDC, EPA, FDA, they all recognize the benefits of UVGI. And now many of these organizations do talk about and recommend upper zone UVGI radiation units, particularly in healthcare facilities a lot. In 2003, ASHRAE formed a technical committee, TC 2.9. So subsequently now, two ASHRAE handbooks, they talk about, they have a separate chapter on UVGI. So there is one handbook which talks about the construction, etc. And the second talks about the application. How do we apply it? And recently this year, a few months ago, ASHRAE came out with the standard 241, which talks about control of infectious aerosols. So with this background, we all will be quite curious to know, if it is known for more than 100 years, why the adoption has been quite slow. So what our team understands is, whenever there is no vaccine, like how we experienced during the recent COVID pandemic, naturally, we all are anxious to spread the infection in workplace, in public place, home, etc. So that time we look for some engineering solution. But once the vaccine is out, which is available almost free of charge at a or at a very low price, so usually end users, they are no more interested in investing in these engineering assistance to take care of the infection spread in the workplace. So that could be one reason, which has been our experience also from the COVID pandemic. But UVGI actually goes beyond disinfection. It definitely enhances the indoor air quality and also helps to save energy. So we will be talking about that in this presentation. So this was the new standard I was talking about, ASHRAE standard 241, talking on control of infectious aerosols. So this covers the new buildings, the existing buildings, and also major renovations and retrofit. This This encompasses the entire air system design, installation, operation, and maintenance. This is not talking specifically about UVGI. It talks about the overall air system design, installation, operation, and maintenance. So with this background, let us now look at the operating principle of UVGI. Is my voice clear? Okay. Shamal?
Yes, sir. From this side, it is absolutely clear, sir.
Great. It is okay, right? Voice?
Right, sir. Right, sir.
Great. Okay. So now let us understand the UVC disinfection, the natural source. Natural source is sun. So as we can see in this slide, whatever visible light that we see, so it spreads over a shade below 400 Newton meter it starts and a little over 700 Newton meter. That is the visible light we are able to see. Just below this light spectrum is the UV rays. So the UV rays are classified into four different groups: UVA, B, C, and also vacuum UV. So this is spread over 100 nanometer to 400 nanometer wavelength. What we are more interested to discuss in this particular session is UVC, but let us understand from the natural source sun, all these UV rays when they are emanating, what happens? Do they all reach Earth or not? This understanding will help to alleviate some of the fears we have about applying UVC in our workplace. So if you see from the sun, we get the UVA, UVB, UVC rays. And we, being from HVACR industry, we all are quite familiar with the stratosphere and the ozone that is concentrated more in the stratosphere surrounding the Earth, above 15-kilometer height from the ground level. So this ozone layer, this acts as a filter. So 100% UVC that is coming from sun is absorbed by the ozone layer. Nothing reaches Earth. UVB, 95% is absorbed, only 5% reaches the Earth. And when we come to UVA, only 5% UVA is absorbed by ozone layer. Balance 95% UVA is reaching the Earth. So this information, please keep in mind. Later on, when we talk about safety, we will be talking about this point once again. With that, let us now move further to understand what is this UVGI. Whenever we refer about UV in HVAC application, the UV, generally what we refer is the UVC band. Between UVA, B, C, and vacuum UV, these four classifications, what is of specific interest to us is the 200 to 280 nanometer band, which is the UVC. Of this UVC, a particular wavelength, which is 253.7, normally we round it off to 254. So whenever we talk of 254, actually everyone is referring to 253.7 nanometer wavelength. This particular wavelength has got germicidal property. It is inherent for that wavelength. We will understand how it is so in the next slide. So there are many research agencies, organizations like DIN, IESNA, who have done a lot of experiments taking different pathogens, virus, bacteria, algae, spores, etc. They have subjected them to UVGI rays. So the x-axis, if you see, this indicates the wavelength of the UV ray. So 100% efficiency, if you just see the y-axis where it is 1, it is cutting. So the 265 nanometer wavelength gives excellent germicidal property. It is able to disinfect the pathogen very, very effectively. So taking this 265 nanometer wavelength, when the industry started commercializing it using low pressure lamp, UVC lamp, we were able to deliver 95% of the energy at 253.7 nanometer. The attempt was to make make it deliver 265, but at 95% efficiency, we were able to get 253.7. So we settled for 253.7 because 95% energy is also excellent. If we can give adequate dose energy, we should be able to disinfect the pathogen very effectively. So because of this property to disinfect the pathogen at 253.7 nanometer wavelength, we refer the UVC ray of 254 nanometer wavelength as UVGI, ultraviolet germicidal irradiation. So whenever now we talk UV or UVC or UVGI, we are actually referring to the 253.7 nanometer wavelength UV rays. Let us now understand how it is able to deactivate the microbe. If you look at the right side, the picture, all the pathogens, they are made up of DNA and RNA. So under microscope, of course, some could be having a single helix form, many are having double helix form. So this is the cell structure, how they look like under microscope. So for easy understanding, we are showing a representative double helix structure of a cell. It could be a DNA or RNA. So when we subject this to 253.7 nanometer UV rays, the cells are made up of lot of protein inside. So this UV ray 253.7 is absorbed by the proteins that lead to a chemical reaction, which leads to creation of some specific agents called pyrimidine dimers inside the cells. This, this is created in many thousands, many hundred thousands. So when this happens, the cells actually starts breaking up. The supporting structure, the protein that is inside, which supports this form of twin helix or a single helix, that starts breaking up. So it is no more able to survive, no more able to replicate, reproduce. So this is what we call as disinfection. So by applying 253.7 nanometer UVGI, we are able to deactivate the microbe. Now, a question may come, which all pathogen can be deactivated? As of now, whichever pathogens are known to science, any pathogen, any microbe, they all will be deactivated using this UVC 254 nanometer wavelength, including COVID virus. So here we have put some of the well-known bacteria, virus, etc., which immediately we will be able to recognize, starting from TB, SARS, hepatitis, measles, HIV, adenovirus, coronavirus, influenza, poliovirus, rabies, penicillin. All these things, these are well known, which we will be able to recognize. So whenever we look at any handbook, they would have given many hundred names of pathogens. They all will be disinfected by using 254 nanometer UVC. Now, this picture is from one of the ASHRAE chapter, Handbook 2020 on system and equipment. If you look at the left side, we have further gone into different groups of pathogens: vegetative bacteria, mycobacteria, bacterial spore, fungal spore, etc. So very nicely, they have arranged in an order of most susceptible, means easily deactivated by 254 nanometer, least susceptible, means you require more energy. For example, if vegetative bacteria requires a particular energy of UV, the fungal spore will require much more energy to deactivate. So that is how it is graded as most susceptible or least susceptible. But as we are in a position to deliver whatever energy is necessary to deactivate the pathogen, generally all these type of pathogens we will be able to deactivate. And virus is very easily disinfected using UVC because comparatively they require less UV energy compared to the spores. Now let us understand some of the terminologies that we associate with the disinfection theory. We also talk about the dosage, the energy, etc. So let us understand about this. And I will try to make it a little easy for all of us to understand without going into too much theoretical formula. Let us start from the curve on the right side. Now we see a curve here. This is one of the uh, pathogen disinfection curve for mycobacteria. This mycobacteria is the bacteria which creates TB in humans. So if you look at this curve, initially when we start applying the energy, it's a little horizontal, means it takes some kind of threshold energy. Once that much energy is reached, so look at the rate at which it is getting disinfected. So it falls very steep exponentially. In multiples, it gets deactivated, disinfected, meaning it is destroyed by UV rays. So it takes a certain threshold and then it starts degenerating, decaying exponentially. So this is sometimes referred as a shoulder curve because there is a threshold uh, limit after which it decays very fast. So this very clearly indicates to us this is applicable for mycobacteria, this particular curve. But we take similar curve for any other pathogen, bacteria, fungal spore, virus, etc. Maybe the numbers, the values may change, but the curve will look more or less similar. Some pathogen can have a single shoulder curve. Some could be having a double shoulder, meaning it will degenerate. Again, it will sort of stagnate. And then with more energy, again, it will degenerate. So the curves could be a single shoulder curve or a double shoulder curve. So this gives us a very clear understanding. We require the right amount of UVC energy, then only we will be able to decay them very fast exponentially. Now let us understand some of the formula we normally use in our HVAC application for UVC. So one of the term we use is, sometimes we refer it as UVC dose. It is nothing but fluence or UVC energy, you may say. Now, the dosage of UV, it is generally expressed in joules per square meter unit or microjoule per square centimeter. So it is equal to the intensity of the UVC, which is referred in microwatt per square centimeter, multiplied by the exposure time. How many seconds exposure we got. A little easy way for all of us to remember this is, this being energy, how do we calculate the electrical energy? We take normal watts multiplied by how many hours we are using it. So many hours. So watt multiplied by hour, for example, it becomes kilowatt hour. That is energy. So you may try to remember that so that this formula becomes a lot more easier to understand. So if you want to generate a particular energy, what we require is a particular intensity of UVC lamp we have to generate, and it should be exposed for a particular exposure time in seconds. So this to please remember. Now we were talking about this shoulder curve for mycobacteria. Then we said for pathogen to pathogen, the curves will slightly change, though the shape may be the same. So on what factor this curve will change? That is called as the K factor, species dependent deactivation rate constant. The way the inside protein are made up of, the way the single helix cell or a double helix cell is made up of, it all depends on that. So this K value is what the scientists find out in the laboratory by doing a lot of research work. We might have seen different companies referring to different dose value for COVID virus deactivation during the pandemic. All of them were right because the K value is very difficult to establish and reach a consensus. Different research scientists will come out with a different K value. So it is always good to refer to a standard handbook For example, what is ASHRAE recommendation? What is CDC recommendation? Something like that, so that it becomes a little more reliable and trustworthy. But there is nothing wrong in a different people using different K value, because if the K value changes, the dosage will change. So the formula is the survival fraction, by what extent we will be able to disinfect the pathogen. This is given by this formula. Now we are talking about this curve. Usually we know the slope of the curve is defined by this K factor, which is a species dependent deactivation rate constant. So this is the formula. We will not be talking about this theory again. We will be talking only about the dosage value, etc. But this explanation might help you to understand what is this dosage this whole UVC industry keeps talking about, and what is the significance and importance of that, how it matters. Now you might be able to understand in a little better manner. Okay. Now let us go into a little more detailed understanding. Many of us might have seen during the pandemic time, like whenever we used to use a hand disinfectant, on the bottle they would have mentioned 99%, 99.9%, right? Okay. So let us understand. So it all comes with a certain science and theoretical background. Let us understand what is that. So this chart, if you see, the y-axis gives the percentage survival rate of pathogen. The x-axis gives the dosage of the UVC. You can say that is the UVC energy that we need to give so that we will be able to disinfect the pathogen. Now, what does this y-axis means? The numbers. 10% survival means 10% of pathogen may remain, 90% is disinfected. This we call as a 1 log reduction. So similarly, 1% survival means 99% disinfection, 2 log reduction. The 99.9 we were seeing on the hand wash, that is 3 log reduction. 0.1% of pathogen may survive, 99.9% will be disinfected. Similarly, it goes up to 7 log reduction. Normally in HVAC application, if we are able to do a 2 log or 3 log reduction, is generally should be more than enough. Maybe for operation theater kind of IAQ environment, where the bacteria virus count may matter very severely, seriously, there we may look at 4 log, depending on what the doctors want. But generally, HVAC comfort application for office, public place like cinema theater, metro station, airport, etc., generally a 2 log, 3 log should be good enough. So this probably might help you to understand the logarithmic scale of reduction we talk about. Now, if you see the 1 log reduction, if it requires 1200 microwatt second per square centimeter energy, a 3 log reduction will require 3700. Now you can understand, if we want to achieve higher degree of logarithmic reduction of pathogen, the amount of energy, it is not linear, but it is exponentially, it is increasing. So this we will have to understand. If at all we want to reach higher level of disinfection, it will require more energy from the UVGI system. So ASHRAE gives a 2 log reduction for CoV-2 virus, just for reference, as 1500 microjoule per square centimeter. For a 3 log reduction, 99.9% disinfection, one of the scientists, Bianca, which further got developed from Kowalski initial research, the value is 3700 microjoule. Now, this is a snapshot from one of the handbooks. It gives a different kind of DNA, RNA pathogens. Some of the names you may be able to recognize. So the handbooks normally give this kind of an information, like microbe type, NCBI, what is the diameter? You see, it is all in microns. Like even the CoV-2 virus, it was so small, tiny. The genome, the genome sequencing was done, what is the reference, etc., etc. And then they give the UV energy value. Most of the researchers will declare D90 value, which is a 1 log reduction. The 1 log reduction is more accurate, may be able to replicate, maybe a consensus, may be able to evolve between different laboratories and scientists. But subsequent to 2 log, 3 log, 4 log numbers, because the K value will change, may not be exactly matching between different laboratories. Okay. With that, let us now move to this. Generally, now so far we have understood the what is UVGI, how it disinfects, what is the some of the fundamentals, technical terms like what is UVC energy, etc. What is logarithmic scale of reduction and all that. Before we start discussing about how do we apply it in AHU, we need to just go through one more section to understand the type of lamps and what is the code and standards that are applicable. First, let us start with UVGI lamp construction. From the picture, immediately you will be able to recollect a normal fluorescent lamp that with tube lights we use at home, offices previously. Nowadays, everything has moved to LEDs, of course. So the construction is very similar. We call this as a low pressure UVC lamp. So to understand how this works, very similar to any normal fluorescent lamp. Here also, this is made of a pure glass. Okay, generally made of quartz or soft glass, because only if the glass is pure, UVC rays will be able to penetrate and come out. If it is some other impure glass, it cannot penetrate and come out. So the glass material is different. Second, this is also filled with an inert gas of a certain pressure. So we call this a low pressure lamp. Now the electrodes are there. So the electrodes are coated with a special coating, and there is a tiny amount of mercury inside. The mercury amount is less than 5 mg by general standards. Some of the powerful fluorescent lamps that we used to use at home or offices used to have more than 5 mg mercury level. So with respect to mercury presence inside the lamp, there need not be any concern. The way we handled our fluorescent lamp before, very similarly, we will have to handle this also. This is no different. Okay. Now, when we switch on the power, that is very similar to the ballast in fluorescent lamp. Here also there is a power assembly. It is called by the manufacturers. It is kept outside. When we apply power, the electrodes gets heated up. Then through the low pressure gas inside, the electrons start moving around. The electron activity starts, and when because we have applied the power, slowly the electrons start impinging on the mercury atoms, that starts heating up. So in this increased electronic activity and the mercury atom getting vaporized and getting charged up, it starts emanating, the whole combination starts giving up 253.7 nanometer UV light outside the lamp. Now, this particular lamp construction is done in such a way, a special coating is applied on the inner surface. Other than 253.7, nothing can come out, because vacuum UV, if the UV wavelength goes below 200 to let us say 185, it can emit ozone. But here, because of the special coating, only 253.7 nanometer wavelength comes out. So there need not be any concern about ozone generation. So it is never a concern with UVC lamps. Now, many times we might have seen manufacturers telling replace the lamp after 9,000 hours or 12,000 hours. Why is this important? What it has got to do with the construction? So why it is important is there is a specific coating that is applied on the electrodes. The special coating gets consumed over time, and if the coating reduces, the electronic activity inside, the electron charge at which speed it has to move, collide with mercury, etc., that gets automatically changed. Because of this, the UVC intensity will drop. So this is the reason we have to strictly follow manufacturers' guidelines to replace the lamps. The lamp may be still glowing, it may be in working condition, but the UVC energy output will be less. So we have to replace them after the manufacturer's recommended hours of usage. Now let us talk about the glass material. So we have quartz glass and soft glass. Now either material can be used for HVAC application. Only thing is, as long as the dosage to disinfect the pathogen is delivered, it's okay to use either product. Both are good. Now let us understand what is the difference between them so that application wise we are better prepared. Now with the quartz glass, the manufacturer, whoever is using quartz, they can generate 254 nanometer supply to HVAC industry for disinfection. They also can make 185 nanometer ozone lamp by changing the inner coating on the lamp glass surface. They can supply to non-HVAC use because ozone is good for removing certain, cleaning some oil surface, wax, etc., grease, etc., even absorbing water. So ozone is required in certain non-HVAC application, for example, kitchen exhaust. So there, the manufacturer will find it a little flexible to use quartz. So he can alter the wavelength and supply to two different industries. With the soft glass, it will generate only 254 nanometer. It cannot be used for generating, for example, vacuum UV, not possible. Ozone, it cannot generate. Now, when it comes to the derating in lower air temperature, we are going to talk about this. What does this mean? So the derating at lower air temperature, this is lower. We use the UVC after the coil in AHU. So we all know the supply air temperature could be depending on the CFM, ADP, other parameters, sensibility ratio, etc. It could be 12, 13, 14, something like that. So let us say it is 13 to 15, for example. So naturally at a lower air temperature, there will be a derating because these are all rated at 25 degrees centigrade. Now, when you come to soft glass, the derating is much higher. So how do we make this soft glass to work inside AHU? So what the manufacturers do is, over and above the UVC lamp, they provide a glass tube shield. So the glass tube shield help to minimize the percentage derating. So this is the reason you might have seen, some of you might have seen in Calcutta, some applications. Some application has only the UVC, some application has UVC and a glass shield over that. Sometimes the contractors or others unknowingly they project it is a protective shield, meaning it is very good. So it is not for protection or giving it strength. The purpose why the double shield is there is to minimize the percentage derating in the living air temperature. Now, let us look at the lamp types and more terminologies. So what we use currently in the industry is low pressure lamp. There is also a medium pressure lamp. Very rarely, there are few applications which use medium pressure, but generally HVAC industry globally and in India use low pressure lamp. So let us understand more about low pressure lamp. So in low pressure lamp, this gives about 31 to 33% output efficiency. Depending on the ampere rating, we classify them as a standard output, a high output lamp. Here the gas mixture and pressures, they are optimized. Different pressure it has, there is a mixture within the gas just to improve the property. So this consumes 800 to 1200 milliamps at very similar lamp dimension. So look wise, for example, if you take a 3 feet or 5 feet lamp, both may look same, but a high output lamp will give more energy. So this we will have to check with the UVC lamp manufacturers, and preferably we should go with high output lamp because it gives higher energy. The third type under low pressure lamp is amalgam lamps. In amalgam, what is amalgam? We know very similar terminologies like the lighting industry uses. Amalgam, the mercury is alloyed with some other elements so that the amount of energy we generate are much, much higher. So this operates at much higher amperes. Again, here the electrode, the gas mixture, the diameter, everything is optimized. So this is about low pressure lamp. Preferably, we should ask the manufacturer and go with low pressure, high output lamps. Now, the latest trend in the UVC industry is on LED. Not yet available for HVAC use in AHU or duct as of now. The reason is here the UVC output is we are able to get 280 or 265. So the efficiency will be more. So it is still work in progress, still not fully ready for HVAC application. One of the reason is it is still evolving. So as of now, they have been able to reach a power output of very small value, 1 watt to 4 watt, which is not adequate for our HVAC application. And the heat management also they are working on to avoid damage. Of course, like how in lighting industry, LED came in a big way. Now it is all LED. Similarly, at some point in future, once these things are addressed, how do we generate more power, higher energy, how to manage the heat, etc. Once they figure it out, maybe in future few years time, we may see LED UVCs coming in to replace low pressure lamp. But as of now, the low pressure high output lamps only we are using. So one application which comes to our mind is using LVD UVC is dental surgery. You might have, in case any one of you have undergone dental surgery, the surgeon usually after making all those stitches and all are on the wound, he or she will show this LED UVC just to disinfect and then they will put the stitches. So as of now, it's in dental application, not at an HVAC. Now, we were talking about the derating, percentage derating in HVAC application because of the supply air temperature. Now, let us talk about that. So, we call this as a wind chill effect. So, now if we, from the construction we discussed, so the energy is usually specified at a particular ambient temperature, generally 25 degrees centigrade. Now, depending on the surface temperature of the UVC, naturally the pressure will change. We know in air conditioning, refrigeration, the refrigeration circuit, refrigerant is moving, pressure and temperature, they are interrelated. Very similarly, if the surface becomes very cold, chilled, naturally the pressure will change inside. So the amount of energy it is able to deliver will change. That is what we call as wind chill. So if the temperature drops, how temperature can drop? Number one, the supply air temperature itself is low. Number two, the velocity can be higher. So because of these two things, the wind chill effect will happen. So ASHRAE has given very nice curves from manufacturers. Let us look at the temperature effect on the left side. So if the ambient is around 40, 45, for this particular specimen of lamp, it is giving 100% output. Now from 40, 45 where it gives 100%, you move to 13 degree, 15 degree in AHU. So this drops to about 50, 55% output, correct? So this is the effect of the cold spot because the temperature of the supply air stream in AHU or package AC or ducted AC drops, the output drops. Similarly, now let us look at the effect of velocity. The standard specification UV energy, they declare at still air condition with no air movement, still air. So in AHUs or HVAC application, the x-axis here gives the meter per second velocity. Now, normally our AHUs we design for 500 FPM. 500 FPM is 2.5 meter per second, right? So at this condition, if you see, if you take a standard output low pressure lamp, so it drops from a still air when it was giving 170 watt microwatt, it drops to about maybe 120 or something. So with increased velocity, the output drops. This is the reason instead of using standard output lamp, we go for high output lamp in AHU. So high output lamp with the still air, if it is 225, it comes to 2.5, almost at same level. Meaning the percentage derating is less, even with increased velocity. So this is the reason we say always ask for low pressure, high output lamp for HVAC application. This will help us. Okay. So this is a last slide on which standards are applicable for UVC lamp. Then we go to the HVAC application. So UVC lamps also use a ballast, very similar to the choke that we use for fluorescent lamp to adjust the necessary voltage to the electrode. Now, because the construction wise it is similar to fluorescent lamp, the specification of UV lamp also most of the time follow similar terminology. Like we call the diameter as T4, T5, etc. because the tube lights we use to refer by that. We also say 3 feet lamp, 5 feet lamp. So we refer it by length, by diameter, by watts, etc., etc. So very similar to fluorescent lamp. So the guidelines are usually from similar industry for lighting, IESNA, NFPA, ANSI, etc. Electrical safety, UL, ETL, CSA, and in India it has to follow India electricity rule also. Now let us come to the UVC performance test. So the UVC lamps, they are turned on for 100 hours. After that, taking a photo sensor, we go to 1 meter distance, 3.3 feet away from the midpoint of the lamp at 25 degrees still air, no velocity, still air, 25 degree. Then they declare this is the energy, UVC energy, this length lamp can give. This is the standard of ASHRAE 185.1 and 2 and also IESNA. Okay, so this would have given lot of input on the standard construction of the lamp, how it works, how it gives UVC energy. Is there a possibility of ozone coming out or not? The difference between soft glass and quartz glass, and the standards and performance applicable for UVC. With this understanding that we have got so far, let us now move to how do we apply it in HVAC. So let us now talk about in two ways it is applied in HVAC. One is for surface disinfection, second is for air disinfection. So surface disinfection, where all do we apply? Number one, in AHU, wherever it is wet surface, dark surface, with availability of dust and dirt, because the pathogens need them as a nutrient to replicate. So all the dusty surface, wet, dark surface, they are all breeding ground for fungi and other microbes. We know in coils we have seen, in cooling tower sump we have seen, etc. Similarly, AHU drain pan also we have seen. So these are all called surface disinfection. If you want to disinfect a static surface like coil, drain pan, even the inner surface panels of the AHU plenum, that is called as a surface disinfection. Here, this is a little simpler. Reason is long exposure is possible, so it becomes very highly effective. You can expose it on a coil for like 6 hours, 8 hours, so it is very effective. So the other side is air disinfection. What is air disinfection? The pathogens mainly come from fresh air and the fresh air intake that we take from outside. Sometimes it could be polluted. And in case of recirculated air, whatever we are exhaling, we are sneezing, coughing, etc. If, for example, any sick person is present, whatever they are giving out, all that is the source for microbes to be present in the airstream, moving airstream. With the moving airstream, it is going at a certain speed. So we get very less exposure time to disinfect. So this is a little more tricky, air disinfection compared to surface disinfection. And we require more energy because the time exposure available is very limited, very less. Okay, now let us understand surface disinfection. How do we apply? So on the AHU's finned surface, many a times we see this kind of a formation. We think it is dust or dirt. By cleaning it nicely with a soft brush or water wash, it all will go. When we do that, it may go, but it will again regrow because this is not a simple dust or dirt. It is called biofilm. So when airborne mold or bacteria, they adhere to a wet surface, they immediately excrete, meaning give out a slimy glue-like substance by which it sticks to the surface, feeding on the dust dirt, it starts growing, replicating in multiples, many hundreds, many thousands. So that is how they start growing on the coil, drain pan, etc. And in many AHU design, of course, the design will dictate how many rows, but generally we see at least 6 rows. Very rarely we see a 2 row, 3 row AHU, very rarely, maybe there. Generally 6 row, 8 row like that design. Only the surface we may be sure, but what is the situation on the third row, fifth row, sixth row inside the coil? Is it clean? There is no way to find out. So coil drain trace, if there is a stagnant water, the pathogens can start growing. So on the left side, if you see two discs. Let me explain what is this. This we call as a Petri dish or a Sabdex plate. All the microbiologists, if any of your friends or relatives are microbiologists, they work in a lab, you may talk to them and discuss about this with them. It's very interesting. So it is hardly our palm size. So this is filled. This is how it looks originally. So it is filled with a chemical which we can roughly translate as a nutrient for pathogen to grow, replicate. So this comes with a lid. Normally this should be kept in a refrigerator till you want to take it to the field and apply it on a surface. Otherwise what happens? It starts drying up. It will wilt. There will be many cracks appearing, meaning it won't be effective. You cannot use it. So generally the recommendation is to keep in a refrigerator. Now this we take it close to a coil. Near the coil, we just remove the lid, touch upon the coil, put the lid again and put a tape so that no further air or moisture can leak into this small plate. Now, when we hold this for 2 to 3 days, this is the kind of growth we see inside. Each and every color you see, white color, yellow color, black color, green color, that indicates a different pathogen. Each color is a different pathogen. So we had a doubt looking at that coil, is it a dirt or a biofilm, right? Whenever we have a doubt, the right thing to do is apply this Petri dish. This Petri dish doesn't cost much. So a packet of 10 or 20 should cost about packet of 20 is available at about 1600, 1500, 1800, that range. 1500 to 2000, you can say. So per plate, it is not even 100 rupees. Okay. So if we are interested to know what is this, it has to be sent to a laboratory where they will grow the culture, remove each and every pathogen. They will subject them to a culture test, grow it at a particular temperature, so many hours holding, etc. Then the scientists, laboratory people will tell what pathogen it is. Now, over many years, all the UVGI manufacturers who are into this field, they have done this time and again and again, years long. So usually whenever you do this, touch in HVAC, inside a AHU, a coil, a drain pan, the surface of the AHU inside, or supply air grill after the duct into the space, mostly you will find one of these. And the aspergillus, which is a fungi, this is always present in a duct, in coil, etc. Always. And there are gram negative and gram positive microorganisms. The gram positive, at least it is susceptible to antibiotic medicine. The gram negative, it won't uh, meaning it is not susceptible to the antibiotic medicine. But even those kind of gram-negative pathogens can be disinfected using UVGI energy. So that is something very interesting for all of us in HVAC industry who cater to different kind of clients, including hospitals. So this will be very, very helpful to take care of disinfecting all the pathogens known, generally seen. I was talking about the laboratory test. So this is how it is sent to the laboratory. Then they will follow a certain microbial procedure, incubate it, etc. Usually the laboratory result will declare a CFU. So if any of you are in the pharma industry, generally in pharma, whenever the quality inspectors come, they check, they will be looking at taking a air sample, looking at the PM count, and also the CFU. CFU is the colony forming unit, which is nothing but the microbial presence in the air. So if the UVGI energy is very effective, we should be able to manage this in pharma and healthcare industry very, very effectively. Now, I will talk about this a little later when we come to energy saving. So whenever the biofilm forms, it affects the heat transfer. It increases the airflow resistance and also presence of lot of microbes. So I will leave it at that. We will come to that a little later. Now let us see how to apply the UVC lamp inside the AHU. Before that, I want all of you to focus on this particular representative number that is shown here. As per the standard, which we saw a few slides ago, 1 meter away from the lamp, we have to measure the intensity. Now let us take on the surface of the lamp, we are measuring 100 microwatt, just for example, okay, 100 microwatt. When we move 6 inch away, 150 mm, the 100 microwatt becomes 13 microwatt. You go to 1 foot, 300 mm, the 100 microwatt drops to 7 microwatt. You go 1 meter away, 3.3 feet away from the lamp, the 100 microwatt on the surface becomes 1 microwatt. What does this indicate? What it indicates is the UV intensity is inversely proportional to the square of distance. Like we know the fan laws and all we keep talking about. With the speed change, this is how the static pressure will be impacted. This is how the energy will be impacted. Something similar is the theory associated with UVG intensity with respect to distance. So the UVG energy drops. Usually on the surface of the lamp, we measure sometimes 20,000 microwatt, 30,000 microwatt like that. We measure that on the lamp. It doesn't guarantee on the coil we get anywhere near that because 1 meter away, it drops more than 100 times. So if on the surface we measure 30,000 microwatt, so 100 times less. So 30,000 remove to 0, it becomes just 300 microwatt. Just for example, not necessarily this is applicable for all the lamps. This is just to give you an idea to keep this particular design criteria in our mind so that we will be able to deliver real effectiveness of disinfecting inside the AHU. Because many a times, some of the clients we have spoken to, met with, they all say we applied UVGI, but we don't find it useful. Some of the reasons are related to this. If you don't understand some of the basic theories, what is energy intensity of UV, how much is required, what happens with respect to distance away from the UV lamp, etc. If you don't understand any of that, and for cost reduction, instead of 5 or 6 lamp, we put 1 lamp or 2 lamp, naturally the energy generated is much less and it is of no use. So this is one thing all of us need to understand. Now, whenever we are going for a surface disinfection, the manufacturer gives this kind of a reflective plate at the back of the UV lamp. It is given by the UV manufacturer. This is having a polished surface, mostly aluminum polished surface. So whatever lamp intensity is there, the reflection further increases the intensity so that we can focus it with more intensity on the coil or drain pan, the targeted place. One of the confusion created in the industry during pandemic time was in one of the ASHRAE chapter, they say 100 microwatt seems to be okay. Seems to be okay. They never say it will work. Okay. So taking this reference, many people attempted to use only 100 microwatt intensity. And they used to switch it off after 8 hours of office use because the whole power will be turned off in the AHU, including UV lamp. Night time, it will be all off. So different pathogens that we saw few slides ago, they have different replication rate. Some pathogens will replicate in few seconds, in few minutes, 2 seconds, 20 seconds, 2 minutes, like that. If we don't understand which pathogen we are dealing with, if we turn it on for 8 hours, switch it off, go home for 16 hours, come back, whatever we disinfected might have grown back to a much higher degree. So this is one reason why some clients do complain the UVGA is not effective, because the intensity is not adequate. We are going to discuss about the intensity a little more in the coming slide. So whatever intensity we design the system for, it should be higher than the replication rate of the microbes present. This is something we have to keep in mind. One more debate that we had previously was, should it be upstream of the coil or downstream of the coil? Now, as we know, anything, there will be a plus and there will be a minus. Okay, some pros, some cons. Now let us take upstream. So from the picture, this is the dampers, grill, etc., filters, coil, blower. It goes to the supply air duct. Assuming we keep the UV near the filter in front of the coil, before the coil, that is called upstream. So what are the pros and cons? One plus point is the return air temperature is 24, 25, right? So the UVC lamps are rated for 25. It need not derate, because if you keep after the coil, there will be a derating. So one positive point of keeping the UV before the coil is the energy intensity is more. Okay, that is the plus point. What are the negative points? In front of the coil, if you stand, remove the filter, you get access to the coil. You cannot see or you cannot get access to the drain pan. You cannot get access to the entire inside AHU plenum between coil and blower. Even these are forming molds inside. If the water spray is more, depending on the maintenance, etc., other conditions, many a times we find mold growth on the inner plenum surface of the AHUs also. So, and next point is, if the UVC is near the coil, near the filter, whoever enters the AHU room for maintenance, removing the coil filter for cleaning, etc., they may be exposed unknowingly to UVC rays. So from the safety point of view also, it may not be the right thing to do. So this is the reason ASHRAE and the entire industry recommends putting it downstream of the coil, after the coil inside the AHU. Once we put after the coil, we get access to the coil, the drain pan, the entire surface of the AHUs also. Interlocking becomes easy. Whoever comes inside the AH room for maintenance will never get exposed to UVC rays. So like that, the positives are more. What is the negative point? Putting downstream, the energy derating will be there, as we saw in the wind chill curves. So there we need to talk to the manufacturers, get the rating chart, always order high output lamps, not standard output. So that should be able to overcome the percentage derating point. Otherwise, putting it downstream is the right way to do it. Now, some photographs just to explain how it works. So if you look at the left side picture first, picked from one of the ASHRAE journal article, a schematic illustration. This comes with a reflector. So it is focusing on the coil because the application is AHU coil surface disinfection. The drain pan is below. So that also will get disinfected. Now real side photographs. So if you see, the reflector is focusing the UV rays. Totally, it is bathing the entire height and width of the coil with UV energy, including the drain pan below. You will be able to see that in the photograph. One thing we need to understand is UVGI is a line of sight device. What does this mean? Wherever UVGI ray is falling directly, it will disinfect. Look at the shaded portion behind the where my cursor is moving, red circle. These are all shade. Here, the UVGA rays are not falling directly, impinging directly. Here, the microbials may be present. The UVG will have no impact here because it is not in the line of sight. Okay. Now on this surface, we have to measure with a UVC meter to be very sure we are generating the right intensity. We will talk about that a little later. Now, how do we select the lamps? So what we do is all the AHUs and coils in our country, everything is non-standard, right? There is no standard size AHU, even if the CFM is 6,000, 10,000, because of the dimension available, different site reasons, constraints, the coil size, the configuration, everything keeps changing. So whenever we we want to apply UVGA in retrofit case or a new AHU, we should know what is the coil dimension, the width of the coil and the height of the coil. So once we know this, from the face area, from the 500 FPM, that is there, mostly it is 500 FPM. Some designs may slightly drop the FPM. So with that, the manufacturers either have softwares to size the lamps, or they have Excel calculation sheet. Using that, they will guide the end users and contractors. Mostly these are available right from 1 foot lamp to 5 feet, 1, 2, 3, 4, 5 feet, they are available. If the width is so big beyond 5 feet, like here the example is 68 inch. So instead of, it will go beyond 5 feet. So we should not try to save cost. What will happen? 5 feet I will cover. There will be 4 inch gap on left side and right side. There the pathogen growth will start. So we should not take that approach. It's better to divide this width and put two numbers of lamps. Similarly, if the area is not getting covered, instead of putting the lamp horizontally, we are also allowed to put it vertically also. If in any edges, we are not able to properly give the required intensity. So how do we select the length and quantity? Of course, as I said, the manufacturers will help with a software or Excel calculation sheet. Generally, it will depend on the operation. Is it continuous or intermittent operation? As we discussed, 8 hours or 24 hours. What is the distance from the UVGI lamp to the coil surface? Generally, we keep it 1 foot away. 1 foot away, because for maintenance purpose, etc., it becomes a little easy. Some contractors bring the lamp very close to the coil, thinking it will give more energy. That is a correct approach. You bring it close, 12 inch becomes 6 inch, the energy is more, no doubt. But what happens, because of the reflector, we won't be able to shine the UVC rays with intensity on the entire height. So when you come close with that particular reflector angle, there will be a lot of shades formed on the coil surface. On a photograph, it may not be visible, but if you measure with a UVC meter, then very clearly it will be visible, or it will become obvious. So we will have to keep that in mind and follow this method of selecting of the lamp. Use the right number of lamp, right length of the lamp. The attempt should be to give required dosage on entire surface of the coil. Usually the center gets maximum energy of the coil. The four corners, they will be having very less intensity. So that is where the pathogens will grow. So we have to take care of it. Now let us talk about airstream disinfection. So when one of the design criteria for airstream disinfection is we have to impart adequate dosage in less than a second. Why this is important in airstream disinfection? If we take 500 feet per minute velocity in AHU, let us convert that into second. Okay, 500 feet per minute divided by 60. So it comes to roughly 8.3 feet per second. So in 1 second duration, the air travels 8.3 feet distance. Some of the AHUs may not be 8.3 feet long, right? Some of the AHUs could be quite small. So ASHRAE says the exposure time required to disinfect effectively is 0.25 seconds to 0.4 seconds. So 8.3 feet per second, if you multiply it by 0.4 second, roughly 3 feet is the distance in 0.4 second the air travels. So in 0.4 second, we should attempt to disinfect the airstream. So we can do the airstream disinfection inside the AHU, provided we have 3 feet clear distance from the coil to the blower inlet. If 3 feet is available, we get 0.4 seconds exposure. Then we will be able to do inside the AHU. Otherwise, we have to do it in the supply air duct. Okay. This is another similar picture. On the left side, a representative picture. On the right side, a side photograph. One thing becomes obvious. The reflector has been removed. So in surface disinfection, we may put a reflector. In airstream disinfection, we remove the reflector. So only the lamps are there clamped on the aluminum structure on the edges. So it becomes a 360-degree illuminating lamp, 360-degree. So if you see the representative picture on the left, the UVGI energy is going in 360-degree direction. So not only the coil drain pan, even the entire inner surface plenum becomes totally disinfected. But for this to happen, we require effectively in 0.4 second, we need 3 feet length. Otherwise, we have to do surface disinfection within the AHU and air disinfection in the supply air duct. So that is what this summarizes. So both surface and air disinfection will use downstream installation. Surface will have reflector, air disinfection will not have reflector. Surface will use lower intensity lamp. Air disinfection will require higher intensity because we get only 0.4 seconds. Surface disinfection is for continuous operation. Air disinfection will be for single pass because we may not get a chance to disinfect the pathogen. We really do not know. Will it keep coming back to AHU again and again? It depends on the air distribution pattern inside a conditioned space. So within one pass, we should attempt to disinfect the pathogen in airstream. So in case we want to put it in supply air duct, the two ways we can mount. One is cross flow. You can see the lamps mounted this way, one below the other. So on the surface of the duct, we can put a drill and insert the lamp depending on the dimension, width of the duct. As the velocity will be very high, 1500 FPM or 1800 FPM in duct, we need to support the UV lamp adequately, hold it with a clamp, because otherwise at that high velocity, like a cantilever, it may bend and break the lamp. So we have to take care of that. They also can be mounted parallel to the air direction. So this is also possible. Now in whichever section we are mounting, preferably the way the reflector plates for surface disinfection, we use a polished aluminum material. Wherever we are mounting within the duct piece, the right way to do it is remove that particular duct piece, replace it with a more polished inner surface of duct, more polished inner surface, so that it will reflect the UV energy more and more. Okay, so that is how it should be done. Now, from the design point of view, compared to the AHU, the velocity is 3 times higher, right? AHU is 500 FPM. Here it could be 1500, 1800 FPM. So if in the AHU we require for 0.4 second exposure, 3 feet distance, in a duct, because the velocity is 3 times higher, you will require 3 times of 3 feet, at least 9 feet length of duct. You have to illuminate with the right amount of energy. Then we can be sure we will be disinfecting the supply airstream. That will require a lot of energy. One other approach in new application could be expand the duct, drop it to 500 FPM, disinfect, and again converge. If possible, in new application. I know in retrofit it is not possible. The site conditions won't allow this kind of a duct modification. But in case we have to do with the existing setup only, please keep in mind it will require 3 times higher energy than in the air handling unit. That particular duct section you have to replace with more reflective inner surface of duct, more polished surface of duct. And while inserting the lamps, we have to also keep in mind no air leakage through that portion, no UV leakage into the occupied space through that gap. etc. And maintenance wise, it should be easy because many times people don't know there is a UVC inside the duct or even AHU. So we have to be careful. uh, it should be easy to replace. Otherwise, after 8,000 hours or 12,000 hours, nobody may replace. It may not be delivering the intended benefits. So these are all the things we discussed. Depending on the duct size, we also can mount the UVGA in 2 or 3 rows. What does that mean? Like how the chilled water coil are in many rows to improve the contact factor. Similarly, assuming this is 1 row of UVGI, giving some distance, maybe a feet or two, we have to do the design calculations. We can have a second bank. After some distance, we can have a third bank. This is one way to increase the UVGI energy. Okay, all this we discussed. Let us now go to IAQ enhancement. So in IAQ, this is one illustration from the ASHRAE handbook. What this shows is AHU equipment with UVGI inside. The supply air is coming from the ceiling, plenum. So here we are, if they say they show a lot of upper zone irradiation units, which are directing their rays towards the ceiling. So about 3 feet to 4 feet from the ceiling, this entire zone is totally irradiated. So it will be totally disinfected. So if supply air can be made to come through the ceiling, passing through this disinfected 3 feet, 4 feet plenum into the space, then that will be an excellent IAQ enhancement, because mainly we go for more number of air changes. As we know, the higher the air change, with every air change, the particulate matter count drops, the microbial count drops, right? That is the very reason why we go for example, 12 air change in a healthcare setup. If this kind of a design is possible, the designer may even think of reducing the number of air changes, because already we have created this kind of a disinfected space through which disinfected air from AHU is coming. So we can further optimize. Now, after the pandemic, many clients are going for wellness certification. The way 10, 15 years ago, the green building certification became very popular. Currently, as many of you know, in the HVACR industry, many clients are now applying for wellness certification. Wellness certification will totally depend on the air distribution theory, how it is managed, how the infection is going to be controlled and all that. So UVGI plays a very important role in helping our clients to go for wellness certification. We were talking about virus being small diameter in size. So this chart on the left side where my cursor is moving, this is a ASHRAE document on infectious aerosol. If the diameter is small, 0.5 micron, it takes 41 hours to settle down, means it will be floating in the air. If the diameter is big, let us say 10 micron, in 8 minutes it will settle down on a surface. So whenever a big office with the cabins, training halls, workstations, etc., there if one person is infected, if the plenum is common, retainer AHU is common, that infected aerosols will reach the AHU unless you have some kind of a facility there like UVGI to disinfect. This person is going to spread the infection in the workstation or cinema theater or in metro station, airport, etc., public places. So here also UVGA plays a very crucial role. Whatever goes, we were discussing air disinfection, the attempt should be to disinfect just in one pass. So this is why we are considering in one pass, it should be able to disinfect. Okay, so I will jump this also, not very important. So the way we in HVACR industry, we are familiar with MERV rating for filters, right? Very similarly, which is so easy, meaning we need not have to think and design a filter. We can simply ask for a MERV 12, MERV 13, MERV 14 filter. It becomes that much easy to apply in practical purpose. Similarly, the International UV Association, IUVA, they came out with a URV rating, because so far what we have discussed, look at the K value, look at the pathogen, which pathogen we are talking about, calculate the energy dosage, etc., etc., becomes a little cumbersome. Every time we cannot do a theoretical calculation every time. So this is a little easier way to adopt. So the URV rating they have come out with, very similar to MERV, how it goes up to MERV 14, etc. They have now gone to a higher level, URV 1 to URV 25. This more than URV 15, these may be applicable in small uh, hospital rooms where the patients are recovering, because there they will be having a UVGI unit with a small circulation fan and filter, because it is a closed room, right? Patient room. So it will be circulating again and again. So there we may think of more air changes or more number of passes through the UV system. That is how the URV rating increases. Okay. So generally the shaded area is what is of interest to our HVAC use. So a dosage of microwatt second, which is nothing but microjoule, anywhere from 500 microjoule to 4000 microjoule generally should be good enough for HVAC application. The URV 13 2000 microjoule should be generally good enough. So this chart shows different viruses like adenovirus, influenza, TB, MRSA, different viruses, to what extent, depending on the dosage, to what extent we will be able to disinfect them. Now, instead of showing in decimal, they have rounded it up to 100. No pathogen can be disinfected 100%. As we discussed, it will be always in some logarithmic scale. But instead of showing so many decimal points, they have rounded it up to 100. So yeah, dosage of URV 13, 12, 14 generally should be good enough to disinfect many of the pathogens. Now, one more approach currently we are looking at, the IAQ designers are looking at, is how do we combine MERV rated filters with UVGI? Because that is what ASHRAE spoke about. That is what our position paper released during pandemic also on UVGI spoke about. How do we use MERV 13 and UVGI, which is very, very effective, which improves the indoor air quality tremendously. So here, what this particular picture is from a journal article by Dr. Banfleck, whom we have heard so many times on ASHRAE platform, and Kowalski. They are well-known experts in this particular subject. So without any MERV filter and URV, they ran a test on 52 different specimen, different pathogens. You can see number 1 to 52. These are all different microbes. So without MERV filter and URV, they ran the test. When they applied the MERV filter, MERV 14, majority of the pathogen got eliminated. Certain pathogen from number 1 to number 34, to certain extent they were present. Otherwise, this gray shade, they are all eliminated. Like the bigger diameter, they all got eliminated. This is also arranged in a diameter ascending order. Now, when along with MERV 14, they applied URV 14 value. URV 14 from the previous chart is about 2000 microjoule value UVGI. When that is added, everything got disinfected except some peaks gray you see here for specimen, some of the specimens that are visible here. Only these peaks remained. Majority of them got disinfected, which is really very, very good. So the idea here is apply a MERV 13, MERV 14 along with a URV 13, URV 14 kind of a, equipment. Now, depending on what level we want to reach, microbial count, please note, there is a word of caution from our side. We should not confuse this with the PM level. Okay, PM level is decided only by filtration. UVGI will not change. The particulate matter level, dust level, it will not change. But the pathogen, the microbial count, the CFU that we are talking about, that gets changed drastically if you put a MERV filter 13, 14 along with a suitable energy giving URV 13, 12 or 15 UVGI device. So that is very, very effective. So this is from the same paper. They took a 10 lakh initial population of microbial size, passed through a MERV 13, dropped to 1.5 lakh from 10 lakh, just with MERV 13. Microbial, okay, not PM, microbial. Then because it filters all bigger diameter pathogens. Then with URV 13, as we discussed, anything will be disinfected. This is a 3 log they have gone for. So from 10 lakh pathogen count, it became just 150 pathogen count. So, uh, so this may give us, the designers, the end users, a lot more idea. It may trigger more thoughts. How do we apply UVGI along with filter in our sites, facilities, and in our designs? It is a futuristic design. So even in future, any pandemic occurs, at least air conditioned space, we can confidently say inside AC space with UVGI and filters, infection cannot spread. That much confidence we will get. Now let us understand how it saves energy. I just have another 10 slides. I will go very fast, 5-10 minutes. So how does it save energy? Now we saw this biofilm forming on the coil surface. This ASHRAE paper says depending on the fouling thickness on the fin surface, this is the efficiency loss. Okay, so ASHRAE has constituted quite a few research committees. So they have come out with research papers. They funded these projects. Generally, they say removing the biofilm with UVGI. Once the biofilm goes, the fin surface becomes clean. This will help to reduce air pressure drop by 21%, overall heat transfer by 14.5%. So if this improves, definitely they say anywhere from 10 to 20% energy we will be able to save. Now let us look at few more research conclusions constituted by ASHRAE. This is all from extracts from ASHRAE handbook and ASHRAE journal. So one research in Florida, 22% air pressure drop reduction, 15% increase in heat transfer. One Singapore research, they say 0.6 degree chilled water delta T increased after removing the biofilm with UVGI, and 11% chilled water flow reduction, because the VFD pump is sometimes programmed measuring the delta T, right, across the chiller, across the AHU. So 11% chilled water flow of secondary pump reduced. Then one more in Florida, they said 14% reduction in air pressure drop, 10 to 15% energy improvement in HVAC system. So all these reports do confirm if biofilm can be eliminated with UVGI, applying properly with right number of lamp, right energy, it definitely saves energy. Now, will it save 10%, 20%? How much do we commit? A word of caution again from us. You have to assess certain things in the field. Just like that, we don't want to throw some numbers and disappoint the customers. We have to promise less and deliver more. So what all things we need to check? First of all, we want to check, is it a fixed speed fan for AHU or having VFD or EC? Because if it is fixed fan, you increase the air friction or reduce air friction. On the energy front, nothing will happen. CFM will change. Energy front, nothing happens. Similarly, VFD pump for secondary. Is it a fixed speed VFD? Fixed speed secondary or VFD driven secondary? Similarly, chiller. All these things we need to assess in the site, and then we can say, okay, by applying UVGI, just by removing these are additional benefits, right? UVGI, we are not applying straight for energy reduction. We are applying UVGI mainly to disinfect the pathogens in airstream, pathogens in surface. But these are additional benefits, improving the IAQ, getting a wellness certification for the end client, saving energy for the end client. These are additional benefits of UVGI. So once we have done this homework, then we can confidently say this will save so much energy. Now from Delhi airport and few metros, generally the number we get is it saves anywhere from 8% to 12% approximately from their experience of monitoring the UV application. Just two more things I will talk about. One is on safety. Second is material compatibility. Then we will see some pictures of healthcare application. Then we will close. Now, let us talk about UVGI safety. Many of you veterans from HVAC industry will be familiar with some of these terms. These are all coming from CDC, ACGIH, and NIOSH, NIOSH. NIOSH is referred generally in our workplace more and more, right? So TLV is the threshold limit value. Up to how much limit in 8 hours a day, day after day, without adverse effect, a person can be exposed to UVGI rays. So this is from ACGH. So from their experience, what comes out is for a 8-hour shift, it is 6 millijoule per square centimeter. Now, if you convert this into instantaneous value, so what it means is 0.2 microwatt per square centimeter. So if intensity measured near a duct, near a AHU, etc. Inside AHU, people won't be present on a continuous basis. So we ignore that. Assuming it is a duct mounted application, below the duct, people are sitting and working, or a hospital application, people are sitting below, like the staff there. They may be there for 8 hours. So if the measured instant value is 0.2 microwatt, then it will be complying to this 8-hour shift. REL is 6 millijoule per square centimeter. So overall, we keep looking at this 0.2. Wherever we measure with our UVC meter, we ensure the leakage irradiation doesn't exceed 0.2 microwatt. The next question comes, what happens? Meaning, what are the safety risks that we carry? If at all we are exposed to UVC rays, as we discussed, it is a line of sight device. So if we look at UVC in energized condition without a spec, now I wear a spec. This is not a pure quartz glass or soft glass, right? It's having some, it's not a pure glass. So UV cannot penetrate our specs. But if somebody is not wearing specs, with bare eye, he looks at UVGI in energized condition, he may get a red eye. So this we call as a photokeratitis. Generally, also the conjunctivitis, very similar to the eye infection we get. No permanent damage occurs. Okay, because we are not going to look at the UVC, because all said and done, it is powerful. It's like looking at a welding torch, right? Even if you want, you cannot continuously look at it. So accidentally we may look at it. So that doesn't cause any eye damage on a permanent basis. So usually it may last overnight and it will go within 1 or 2 days. So the idea of sharing this information is not to make us reckless and uncaring. It is just to give us some very good information, so that if at all we are walking into a AHU with UV lamp energized, at least we will remember to wear a spec, at least a plain glass, so that UVC doesn't penetrate and harm our eye. Very similarly, effect on skin. If we are wearing a full hand sleeve shirt, that should be good enough. It doesn't penetrate. And we have to cover all the skin on our body. Like, for example, we have to wear a overhead mask, a gloves, so that hands are not exposed. Shoes we should be wearing. Off trouser won't be allowed. We have to wear a full trouser. If the skin is fully covered, nothing happens. Now, if at all skin is exposed, what happens? Very similar to, you remember that initial chart I asked you to remember. So many people, we go for sunbath on the beach, etc. What happens after lying in the sun for 2 hours, 3 hours and all that? We get a reddening of skin, right? So that is called erythema. Very similar thing. So if our skin is exposed unknowingly to UVC rays inside the AHU, that particular portion may become red. It may cause irritation, but usually it doesn't cause any skin cancer or something, because we are not going to stand there exposing our skin for 8 hours or more number of hours. Accidental exposure for few seconds or a minute doesn't really cause any permanent damage. So ASHRAE 2020 handbook also says it doesn't leave any permanent damage. So now we come to some practical application and photographs and measurements. So you can see this person in the photograph is fully covered, wearing a gloves, head, everything is covered. He is wearing a spec also, plain glass, so that even his eyes are covered. So this is the UVC meter we use. When we measure around the AHU, because here the UVC is after the coil, usually the leakage will be zero everywhere. All the 6 sides of the AHU we measure in the AHU room, it is zero. It doesn't penetrate the sheet metal and come out. Now look at the coil measurement. Some of you may be interested. Whenever you come across any client or anybody else who is a little dissatisfied, I applied UVGA, but I don't see any benefit. Why they don't see benefit is in front of our eyes. See this measurements, field measurement. On the lamp surface, the measurement is 40,000. Now, this is a coil. Dimension is given here, 54-inch by 44-inch actual field coil. So this we marked the 4 corners, 1, 3, 4, 6, centers 2, 7, 5. As I said, the centers 2, 5, 7, 7 you see is the exact center, very high intensity. It will be always like that for all the coils. But just by keeping the center of the coil clean is not going to give the full benefit we want to get from UVGA. You need to give intensity across the width and height of the coil. So look at one number is one of the corner, 55 and 162, not adequate. Similarly, point number 4, 296, 321. This is slightly better. Maybe the lamp is a little towards the left. That is a possibility because even 3 number is 195, 165. And if the gap between the lamp and point number 1 where we are, even these things matter, the distance between the lamps. So after making the measurement, if we find it to be falling short, now what is the course correction here? If this is the client who is complaining it's not helping, wherever we see the intensity is less, either we can add more lamp, the 3 can become 6, or we can add a lamp from 1 to 6, from 3 to 1, 3 to 4, 4 to 6, like that on the edges of the coil. That also will increase the UVGA intensity. So it is all up to us, what we have understood, how do we interpret, how do we measure, and how do we really deliver the effectiveness to the client. In some application, if the client doesn't want the glass to break, as I said, it is very similar to handling fluorescent lamp. If at all the client says no glass breakage, this kind of a FEP sleeve is available from the manufacturer. So even if with a spanner you break the lamp, nothing will come out. Okay, this is the some of the photographs. Nothing comes out, nothing spills, but naturally this is costly. The sleeve is designed specially to emit the UVC rays outside. Otherwise, it will block everything. So this is a little costly, but in certain application, if the client wants, you can order it from the manufacturer. Now we move to the compatibility. Because there were fears, will it melt the wire, will it melt the filter and all that. Let us look at it and understand what is the impact of UVC on the material. So inorganic material like metal, glass fiber, they are not affected by UV rays. It reacts only with elastomers, specific rubbers, okay, and other such organic material. So what are these in AHU? It could be a door gasket. Generally, they are all certain rubber material. The filter elements, they use a special adhesive to bind them together. So that binding agent, we need to understand what is that binding agent material that may get affected by UVGA. So the material degradation will depend on the UVGA intensity, time of exposure, and material composition. So this is further explanation, effect on filters. So usually the binders, what are used, sometimes they may be affected by UV. Filters of solid polymer, they have no effect. And normally the HEPA filters, they use woven media, laid up glass media. So the HEPA is not affected by UVGA. So using the UVGA downstream, so there need not be any concern that using UVGA in AHU will damage the filter because we are putting it downstream, not even upstream near the filter. So we need not have any concern at all. ASHRAE constituted 2 research committees. They came out with these 2 research papers, RP 1509 and 1724. Some of the extracts we are going to see in the next 1 or 2 slides. So what they did was, because UVC will react only with polymer, certain rubber, they picked 50 plus polymeric components used in HVAC AHUs. They picked only polymer And then they came out with this data. Rating A, no effect. Rating B, minor effect, cosmetic. For example, we have our electric cable of split AC hanging outside our house or office, exposed to sun rays. 95% UVA rays reach Earth, right? Only 5% is trapped by ozone. After years, they become not black color cable, they look more whitish, grayish, right? So that is the UV effect. So that is called cosmetic effect. Color may change, no change in ability to perform. Moderate effect, slight pitting, cracking may see. So here we may think of consider shielding using some other metal over that part. Rating D, severe effect, not recommended. So some example quickly we see. Nylon, that is rating B, no effect. Copper, petroleum, Buna NO ring, an EPDM ring, silicon ring, no effect. Minor effect, only cosmetic, color may change, nothing happens. So these are all rating B. Rating C, some of that if you see, polyurethane door gasket may show slight pitting or cracking. Sometimes HEPA, HDPA, LDPE, etc. may be used as a drain pan also. Not everybody uses metal drain pan. If at all somebody has used this kind of LDPE, HDPE, we need to check whether it will react with UVC. Next slide gives that. Some of the items like PET, etc., it is rating D. Severe effect, they are not recommended. If at all they are there, we have to cover it with metal covers. So if we take a LDPE drip pan, it is having negligible impact at less than 1000 microwatt intensity. If the intensity is more, fissure or leak may occur after several years. So this is one research report finding. Electric cable, if the intensity is more than 11,000. Now, within AHU, we have never seen 11,000. Very maximum we have seen is 2,000, 3,000, like that intensity. If it is 11,000, you take a 2 mil thick PVC wire, it may short over 8 years. So these are some of the information available from this research report. Why we have included this information is for HVAC designers, contractors, and users, not to get scared by uninformed information. So please refer these ASHRAE research paper outputs. Some of the findings are also available in ASHRAE handbooks. Please refer them. There is nothing to panic or fear in using UVGI because UVGI gives a lot of benefits. So we know all these things are really of not that much of a concern. It is definitely within our capacity to handle and address. So we should always check with UVGI manufacturer whenever we have any doubt, and we can refer all these available material. Maintenance. One input we regularly receive from field visit is many a times clients don't know the AHU has UVGI inside because people might have changed. There is no logbook which records that, etc. For example, such stickers we should use on the AHU, on the duct, etc. At least from this, people will come to know there is a AHU inside. From the safety point of view also, they will be a little more careful. If at all dust is forming on UVGA, we can wipe it with a soft cloth wetted in alcohol. We should not touch it because fingerprints will affect the radiation intensity. At end of life, 8,000 hours, 12,000 hours, we have to update the asset record, logbook, etc., so that they have to be replaced compulsorily. One thing we very strongly recommend from our E111 UVGI TG is start using these Sapdex plates, which doesn't cost 80 rupees, 70 rupees. We can definitely afford. So if UVGI is used inside, start applying the UVGI at a particular spot. Maybe from the coil drawing you saw, 1 number, 4 number, like that. You decide. Fix them. Maybe what you can do is touch the plate after 48 hours. Keep taking pictures. Week 1, this is the picture. Week 2, this is the picture. Week 12, this is the picture. At some week, it should become like this. Then we can be sure the UVGA is really effective. This also gives a lot more confidence we are able to disinfect the pathogen. We are able to surface disinfect. We are able to airstream disinfect. So this is one more thing we strongly recommend to be included as a part of maintenance in all the facilities. This will really help us and keep us moving forward. My last section, few photographs, how UVGI is used in healthcare. The upper zone irradiation unit, it is mounted above the occupied zone. If this person is, let us say, 5.5, 6 feet tall, usually it is 7 feet and above. The UVGI lures are focused towards the ceiling so that the leakage radiation doesn't hit the people, right? So it is focused towards the ceiling. And at this occupied level, when you measure with your UVC meter, you see 0.2 indicated here. It is that leakage radiation. You may remember from that table that we discussed, it should be less than 0.2. And using this upper zone irradiation unit give effectiveness of microbial presence control equivalent to 2 to 6 air change effectiveness. You can now understand how useful it is. Some photographs. This is how the upper zone irradiation units look. Even corner units are available to put in the corner of two walls. Ceiling hung units for very big malls, halls, hospital corridor, etc. So this is how it works, pictorial representation. At the very top, we create a disinfected zone with a simple air circulation, convection current, or with a ceiling fan. We can further improve the effectiveness. Second device, portable device. So this device, it uses a HEPA filter, UVGI, and a blower fan with two outlets, one at the back, one at the front. So you can close the front outlet, use the back outlet, put a drill on a window or wall. So what happens is you can convert any given small hospital room into negative pressure room by doing this. You exhaust more air than the supply air, automatically the room become a negative pressure room. And whatever infection is there in this room, it will not infect anybody outside because you are passing the air through HEPA and also a UVGI. In case you want to create a positive pressure, remove this, connect from the front, simply circulate the air again and again. For example, certain pharma installations, hospitals, wherever the air quality test, sample test, throws up larger CFU numbers, which is of concern. You want to control it down in a pharma or in a hospital. Such units can be thought of because these are with caster wheels. So these are mobile units. You can take them to anywhere. Another third device is handheld UVGI. We using this by energizing, we can disinfect any surface, a table, a wash basin, patient bed, etc., handrail, any place of concern where we think there could be some microbe which will infect somebody else, we can disinfect using this handheld device. Now, operation theaters, another device. This is called portable in-room disinfection unit. You know, normally after operation, there is a big procedure. Some hospitals even take 1 or 2 days, fumigation and all that to prepare the operation theater. By wheeling in this kind of a heavy, powerful UVGI lamp, nobody should be inside, okay, when you switch on. You have to stand outside and switch on, close the door with a signboard, UVGI inside, don't step. It should be interlocked also with the door limit switch. Then this kind of powerful lamp will disinfect and make the whole operation theater ready very fast within minutes. So depending on the room size and all, the UVGI manufacturers can help us in selecting the equipment. In the US, when the N95 masks were in shortage, this was used to disinfect used N95 mask and reuse. Now you can understand how effective and powerful UVGI is. So with all this information, I come to my summary slide. So adopting UVGI definitely helps us to contain infection spread through airstream in HVAC space. And it actually future-proofs our air-conditioned space. The MERV-rated filters, when we combine them with URV-rated devices, it really enhances the indoor air quality. It helps to further optimize the performance, the first cost and energy cost. So with all this information that is available with us, we can use UVGI technology, adopt them appropriately, help our clients go for wellness certification, enhancing their IAQ in workplace and public places, and also attain much higher energy efficiency than what they are getting in their HVAC systems right now without UVGI. So that's all we have from our E111 technical committee. Thank you very much.
Thank you, Raghavan sir. I will request audience if anybody is having any question.
Any
Sir, I
input,
have a
suggestions, feedback from your side?
sir. I have a. I will not say it's a question. Rather, when we suppose we decide to go for a UVGI, now what are the selection criteria to be furnished? I mean,
So as I said, understood. Assuming it is a normal HVAC AHU in a software company or a hospital, okay, any application you can think of, airport or metro, cinema theater, etc. Very first thing is normally we are going to see similar set of pathogens as we saw in that PowerPoint slide. All those fungi and bacteria will be present always in the supplier grill, inside the duct, inside the AHU coil, etc. So the easiest thing for us to do is, rather than doing a research again, what pathogens are present and all that, we understand in HVAC what pathogens are present. So if you want to do a retrofit in an existing facility, the easiest way to go for is measure the coil size, as we saw in one of the slides. So measure the coil width, coil height. Usually the velocity will be 500 fpm. Please verify that it is 500 only. If the velocity is lower, it is well and good. It will further improve the UVGA effectiveness. And then with that information, we will have to get in touch with UVGA manufacturers and ask them to help you with. Now, if you have 3 feet space between coil and blower, 3 feet, because that 0.4 seconds exposure for one pass disinfection of airstream, that requires 3 feet. How that 3 feet came, I think all of you understood that. We designed the AHU for 500 feet per minute velocity. So 500 fpm divided by 60, it becomes 8.3 feet per second. If 0.4 second is the exposure time for effectiveness, so 0.4 you multiplied by 8.3, you need at least a 3 feet. So if that 3 feet distance is there, you can attempt air disinfection and surface disinfection together. You don't need separate UVGA. So you go for a 360-degree UVGA lamp, not one lamp. How many lamps are required for your coil? You will have to check with UVGA manufacturer. You have 3 feet. You do tell the manufacturer, I need a 360-degree lamp. This is the coil size. This is the space available. This is my CFM. So please suggest how do I do air disinfection and surface disinfection. Then for the coil size, they will recommend you the number of lamps to be put in vertical and horizontal shape. So we go about implementing that. Did that help?
yes, sir. I have understood this. Thank you.
Yeah. And the effectiveness has to be checked by actually measuring with a UVC meter inside. And the whoever is maintaining the facility, they will have to compulsorily record the way they are recording. Filter cleaning was done on such and such date. Next cleaning is due on such and such date. Similarly, they will have to write in the logbook. The last time the UVGA was replaced was on this month, this year. It will be due for replacement after 8 hours, 8,000 hours or 12,000 hours as recommended by manufacturer. On this month, this year, they will have to record that for sure. And this SAPDEX plate that we showed, that is a very effective tool. After implementing UVGI in a retrofit, the facility maintenance person can touch the AHU surface at a particular spot. After 48 hours, he can take a picture, put it in the record. This is week 1 or week 2. Then again, he can repeat it after week 4, week 6, week 8, etc. We will definitely see the pathogen count reducing after 48 hours of holding that SAPDEX plate. So that will be very interesting and very effective. That will give us confidence. Then we will apply it in all the AHUs. Because once we prove it, it is available for demo, that gives more confidence to the users to apply it.
Okay, I understand there is no further question from audience. So on behalf of Kolkata History Chapter, I thank Raghavan sir for really giving us a lot of immense input for this UVGI. In fact, honestly speaking, I was never aware of the power of this UVGI. Previously, of course, I have used it, but honestly, I did not know the importance of such a small light, and it can really do a miracle. After today's this knowledge sharing session, I really understood, and henceforth, definitely, we will try to use as much as possible. And of course, COVID has also made us learn a lot of things about it. So, sir, once again, thank you for your huge knowledge in this subject, and really bestowed a lot of things for us. Thank you very much, sir.
Thank you. And this presentation I will share with Mr. Burman. So
Yes,
it is
sir.
available to all of you. So in case you think this is going to help your clients in any way, please use it and give a credit to ISHRE E111TG. Thank you.
Right.
Raghavan
Thank
sir,
you, Raghavan sir.
hello.
Yeah.
Hello. Good evening,
Yes,
Raghavan sir.
Mr. Yes.
Thanks for sparing your time for this immense knowledge sharing session, and also the sponsor. I would also take the privilege of thanking them for this technical know-how of the UVGI. Okay, so we'll keep on getting in touch with you for the future. Any programs if we can arrange physically, also we'll discuss with you. And hopefully the audiences who have been, because we have just, our puja has just started. Okay, from tomorrow it is just getting started. So
Correct.
we might have a limited audience, but I believe the people who has been here, they got the insight of UVGI in a immense manner, and this workshop for almost 2 hours it has been, the people has been present for 2 hours, and thanks Mr. Bose for hosting this such an event for the Kolkata chapter. And officially I request Shamal Borman to give a vote of thanks to all the participants as well as the sponsor and Mr. Raghavan. Thank you.
Thank you, Shankhoda. Really, it was a very elaborative and detailed insight on UVGI system, sir. As Bruce sir rightly mentioned, we have used UVGI system, and but what we didn't know a lot of things of UVGI. Definitely, many things has clarified today, sir. From ISHRE Kolkata chapter, we all thank you for this delightful and eventful, this excellent presentation. And we definitely, as our president Shankar Bhattacharya says, definitely will be associated in future presentations, also in future sessions also. And regarding this recording, sir, I'll definitely share it with you so that it can be uploaded to ISHRE website. Thank you, sir.
Yes. Thank you very much. Thanks for the opportunity. I will send the PPT to you, Mr. Shamal.
Right.
So if somebody is interested, you can share with the ISHRE members.
Okay.
Yeah,
okay. Okay, sir. Thank you.
Thank you. Good night. Thanks.
Good night.
Thank you. Thank you.
Thank you, everyone.
Thank you. Good night.
Good night. Good night.